Hey everyone, this is your video on what you need to know about the distributive property involving integers. Make sure that you know your integer rules for multiplication and division before you can even try any of this. Remember that positive times positive numbers give you positive answers. Negative times negative questions give you positive answers. And positive times negative numbers gives you negative answers. This is the only one where you're going to get a negative answer. Let's look at some examples. In this one we have 4 times the quantity 3y plus 4. I say quantity because if I were to say 4 times 3y plus 4, the way that I said it only will distribute the 4 and the 3. Not the 4 and the 4. Instead, it would look like this, which is not what it's actually asking you to do. So that's why it's important to actually say the quantity of 4 times the quantity 3y plus 4, which I have shown here, where the 4 is being distributed to the 3y and the 4. Model with algebraic tiles, this is what you were given at first. You have a 4 times the quantity y plus 4, or 3y plus 4, I'm sorry. So now I need to distribute that. I end up with 12 y's and then the constant of 16, and this becomes my final term, 12y plus 16. There's a different way that I haven't shown you yet, and that's called the area model. In this instance, we've got 4 times the quantity 3y plus 4, and I'm going to show that. If you see parentheses, that's always going to mean that the numbers go outside the rectangle. It's kind of like an upside down GCF LCM ladder, or at least that's what it looks like. Then I'm going to apply the same principles. 4 times 3y gives me 12y. And then 4 times 4 is 16. If you work with lattice multiplication, dropping numbers into those squares, it's the same principle. Now, let's look at the distributive property questions using some negative numbers. Remember, you must remember your integer rules for area and division. In this question, I have negative 2 times the quantity 2x plus 3. That is represented here in my area model. I've got negative 2, 2x plus 3, which is what I have written out here. And then I'm going to distribute negative 2 times 2x plus negative 2 times 3. That gives me these negative x tiles and these negative constant tiles. Now there are two ways that I can write my answer. I can say negative 4x plus negative 6 or 4x minus 6. To me, this makes the most sense, but they are both equivalent, and you must be prepared to see it both ways and recognize that they are equivalent. Now let's use the area model with the question that was just given to you. Negative 2 times the quantity 2x plus 3, which is what is represented here. Negative 2 times 2x gives me negative 4x, and negative 2 times 3 gives me negative 6, which again gives me these answers over here, which again are equivalent. If you want, you can click on the algebra tile link on the website to use it for practice if you would like. That is located under both Math 7 and Math 7 Plus on those specific web pages. Now let's look at these expressions written in reverse. Many of you on the last quiz were able to definitely distribute numbers if they were written like this, but you were not able to work with that if it were written in reverse. In this question, I have the expression 3y plus 6. I've got to figure out what goes on the outside to make this work. To do that, I have to consider what the GCF of both terms are. Now, in this instance, when you're working with distributed property, you can also have variables included in that. In this instance, 3y plus 6, my GCF was 3. That means that that 3 is going to go here, as resembled on the next slide, 3. And then I have to ask myself, what times 3 gives me 3y? Well, that's a y. And then what times 3 gives me 6? That's 2. So that gives me an equivalent expression of 3 times the quantity y plus 2. Now let's use the area model, looking at the exact same question. Instead of writing my numbers on the outside, I put them on the inside. 3y plus 6. The GCF of that, again, was 3. That goes over here on the side. Then 3 times what gives me 3y? That gives me the y. And then 3 times what gives me 6? That's the 2. Giving me the equivalent expression, again, of 3 times the quantity y plus 2. Now let's look at this example. In this one, we have 16y plus 20. That was written here. I calculated my GCF of both of these was 4. 4 times what gives me 16? That's 4. And I have to add a y here because that y was associated with this term in the beginning. And then 4 times what gives me 20, which is 5. This gives me the equivalent expression of 4 times the quantity 4y plus 5. But what if they are negative numbers? Let's look at this. Negative 3 times the quantity negative 2y minus 4. To me, it just makes a lot of sense to use color. You can use a regular pencil and then highlight this with pink, or use a red coloring pencil. Because the expression was given to you this way, it's going to go on the outside of the rectangle. I have negative 3, negative 2y, and negative 4. 3 times negative 2y, well, negative 3 times the negative 2 is going to give me a positive 6, and I'm going to give the y to it because it was associated with that term in the beginning. And then negative 4 times negative 3 gives me 12. That gives me an equivalent expression of 6y plus 12. You will find, as you continue to work with the distributed property and integers, especially as you go into Math 1, that there are more than one correct solution when factoring. When you started factoring last year, you were only given positive numbers because, well, they're the easiest to work with. But as we work with negatives, you will find that expressions can have equivalent ways that include both negative and positive numbers. If you're only being asked to give one, that's all you need to do. Just recognize that when you factor, you can have more than one right answer. Let's look at this expression, negative 24x minus 36. In this one, I plugged them in, the rectangle itself, and then I found greatest common factors. Here's a perfect example of what I was saying earlier. I'm going to factor out negative 12. Well, negative 12 times 2x gives me negative 24x, and negative 12 times 3 gives me negative 36. So my answer ends up being negative 12 times the quantity 2x plus 3. But that's not the only way I could have written it. What if I had decided to use a positive 12 instead? If I had done that, and again, this would be right, 12 would be on the outside, but then I would have negative numbers to work with on the inside. I would have 12 times negative 2x and 12 times negative 3. Both of these answers are correct. Try these questions using either model that you want, pause it, and then you'll get the correct answers at the end. Okay, we have 27x plus 36 is equivalent to 9 times the quantity 3x plus 4. In number 2, negative 4 times the quantity negative 5x minus 6 equals 20x plus 24. In number 3, I have negative 4p plus 12, which its equivalent would be 4 times the quantity negative p plus 3. And in the last question, negative 2 times the quantity 3y minus 3 gives me negative 6y plus 6. Please watch again and or ask questions in class. Thanks.